students, welcome back to my YouTube channel Leon Crackers for cracking IIT and NEET. So today in this video we are going to discuss about how to find an equivalent weight for a given reductant or oxidant or in a given neutralization reaction, the two reactants, right? So remember one important trick better here. In any chemical reaction, 1 equamole of one substance should be reacted with equamole of another substance. So based on equamoles only the total complete chemical reaction is occurred, right? So based on equamoles, either reduction reaction or neutralization, whatever, equamole of one reactant would be reacted with the equamole of another reactant. So how to find these kind of tricks, and after doing these tricks, and you may do that so solving problems of redox reactions, neutralization reactions, titrations. Okay, let's see. And I told you, in any chemical reaction, either redox reaction or neutralization reaction, in any kind of reaction, so how it follows, equamole of one substance should be reacted with equamole of another substance. And you must know one difference between equivalent weight and equamole signs. So this EQ is nothing but equamole. EQ is nothing but equamole, whereas EW equals to equivalent weight. And this equivalent weight, you know already that what is the equation? Molar mass upon N factor. So if you know the N factor of the given reactant, then you can find that equivalent weight. Okay, let's see that one. First, before going to do that one, so we must know that equivalent weight, equamoles and equamoles two substance. And how can you write this one? What is the mole equation actually? Mole equals to, so weight given mass upon molar mass of the substance. Here also equamoles equals to, how can you write? Weight of the first substance upon equivalent weight of the first one, and equals to weight of the second one upon equivalent weight of the second one. And this equivalent weight, how can you write? So molar mass upon N factor. I am writing this one. So weight upon molar mass upon N factor, and equals to weight of the second substance upon molar mass on N factor. And you can modify this one, N1 of weight upon molar mass equals to N2 of weight upon molar mass. And this weight upon molar mass, what is the equation? Moles. So overall, what is the conclusion here? N1 into, so moles of the first substance would be equals to N2 into moles of the second substance. And if you know individual, only in a chemical reaction moles are mentioned. 1 mole of one reactant will be reacted with 2 moles of another reactant. Then at this point you must know the N factor. Because if you know N factor, then you can find that reduction, titration reaction, either redox reaction or neutralization reaction. N1 into moles of the first substance should be equal to N2 into moles of the second substance. Or else if they mention directly, so this is a gunshot, because it is always 1 only, 1 equamole and 1 equamole. There is no 1 2 and 1 3 something. 1 equamole of first substance would be reacted with 1 equamole of other substance. So what is the different thing here? N factor would be different and number of moles would be different, but equamole should be equal to each other. And how to find this one, this trick? And you know that one relation between normality and molarity. So normality equals to N factor into molarity. At the same manner you have to remember this. So equamoles, instead of equamoles, how can you write this? 1 equamoles equals to N factor into number of moles. See the difference, see the similarity. So normality equals to N factor into molarity. Equamoles equals to N factor into moles. And before doing this one, so what is N factor? If you know the N factor, then you can find. Actually N factors are overall 5 types. 5 types N factor. So N factors are overall 5 types. The first one for acids. For acids, how to find the N factor for acids? And you can say for acid, this is a basicity. For acids, you can say basicity. And what is basicity? Number of H plus ions. That too, this for acids only for strong electrolyte. For strong acids, number of H plus ions would be removed. The number is nothing but basicity or N factor for that acid. Suppose if you take strong acid HCl, so number of H plus ions would be removed how many here? 1. So that's why what is the N factor for this HCl? 1. If we take strong electrolyte H2SO4 acid, and how many H plus would be removed here? 2. That's why what is the N factor for this acid? 2. Like this. So first kind of N factor for acids. Second one for strong bases. For strong bases, and you can say here acidity. For strong bases, you can say here acidity. And what is this here? Number of OH minus ions removed. Number of OH minus ions removed. Suppose if we take strong base NaOH, how many OH would be removed here? So 1. That's why what is the N factor? 2. What is the N factor? 2. And if you take barium hydroxide and valency is 2, so number of OH would be removed at 2 here. That's why what is the N factor for this strong base? 2. And this is the second kind of N factor. So first one over for acid, second one over for bases, and third one for salt, for common salt and normal salt. For salt equals to, and how to find the N factor for this one? So either total positive or negative charge. Either total positive or negative charge is the N factor for a given common salt. So let's suppose if we take NaCl, total positive charge is +1, total negative charge is -1. So you have to take the magnitude only, not signs. So what is the N factor here? N factor equals to 1. And if we take MgCl2, so total positive charge is +2, total negative charge is -2. Of course, if we take common salt, neutralization would be there. So means positive and negative should be equal. Okay. So what is the N factor for here? MgCl, N factor is 2. And if we take AlCl3, so what is the N factor here? Number of total positive and negative charge would become 3. That's why N factor for this common salt is 3. So 3 kind of N factors are over. For acids, basicity. For bases, acidity. For common salt, either total positive charge or negative charge. Either total positive charge or negative charge. The next one, for weak electrolytes. For weak electrolytes, and this is not important, but for weak electrolytes, either weak acid or weak base, and it depends on Ostwald dilution law, right? And you have to find this Ka equals to C alpha square, and depends on degree of dissociation. You are going to find that N factor. So because it is, of course, here it gives what? HCO minus plus H plus. If it is strong electrolyte, it gives 1 H plus completely, but this is not strong electrolyte. So always N factor would be lesser than 1 for this formic acid. So depends on degree of dissociation, either 0.9, 0.8, 0.7, 0.5. Okay, you can find whatever. This is for weak electrolytes, either weak acids or weak bases. How many are over so far? For acids, 1. For bases, second kind of N factor. For common salt, third kind of N factor. For weak electrolyte, either weak acids or weak bases, fourth kind of N factor. And the last one is most important. Of course, that is our topic actually, right? Next, the last one is N factor for redox reaction. N factor for redox reaction. N factor for redox reaction. So what is the N factor here? Number of electrons to be transferred per 1 ion of either reductant or oxidant. So definition careful. Number of electrons to be transferred per 1 ion. This is very important. In the equation, if you get 2 ions and 4 electrons, then you have to choose per 1 ion how many electrons are there. That would be the N factor for the given either reductant or oxidant. So this is our important n factor actually, because we are discussing here equivalent weight of the redox reactions, right? So now if you take any kind of balancing equation, suppose the redox reaction between potassium permanganate plus oxalic acid, and of course in acidic medium is mentioned. Suppose in acidic medium potassium permanganate converts into Mn+2 and it liberates CO2 gas. So in this we don't know the balancing equation. Of course you can find the overall balancing equation, or you can find the off reaction based on the off reaction. So you can find easily n factor for the given compound or reactant or oxidant. Suppose if we take balance this equation, MnO4 minus 2 Mn+2, MnO4 minus 2 Mn+2. So what is the balancing equation rules? First one we have to write the separate equation. Second one, so equalize the number of ion atoms which oxidation number is changed. Now add appropriate number of electrons to get the ion neutrality. Next, add water molecules by balancing that oxygen atoms, like different conditions are there. So here how many atom? Manganese only one atom, here manganese also one atom. So you can write x equals to +7, here x equals to +2. So difference of how much? 5 electrons. So this is what 5 electrons to be added. It is reduction, that's why KMN4 is called oxidant. Now here important equation. If you want to find the equivalent weight of potassium permanganate ion, you have to choose per 1 mole of 1 ion of this one how many electrons would be transferred. That is exactly n factor. Always you are not getting the n factor equal for these two reactant as well as products. Sometimes you make it different also. Okay, let's see in future. So in further reactions, MnO4 here, if you want to find out the equivalent weight of MnO4 minus per 1 mole of this ion how many electrons to be transferred, that will be the n factor for MnO4 minus only. Now in this balancing equation only one ion is there, 5 electrons are there. So n factor for MnO4 minus is 5, and you can find this molar mass of MnO4 minus upon 5, and this is the equivalent weight of potassium permanganate. Of course it is mentioned in the exam, or else you are going to find that MnO4 minus what is the equal molar mass. After that molar mass upon 5. This is the n factor for potassium permanganate for the given equation. And oxalate we don't know, and equivalent weight of Mn+2, here also in this balancing equation 1 ion 5 electrons. So n factor of Mn+2 is also 5, and you can write directly molar mass of Mn+2 upon 5. Molar mass of Mn+2 upon 5. And the next off reaction, so oxalate converts to CO2. If you balance this one, 2 carbons, and 2x equals to, what is the equation? +6, here 2x equals to +8 you can get, and difference would be 2, so you can write here 2 electrons. Now here different. If you want to find the n factor for oxalate, per 1 ion 2 electrons are there. That's why what is the n factor for this oxalate? 2. But when carbon dioxide, 2 molecules and 2 electrons, but definition is what? Per ion or per 1 molecule, you can say per 1 molecule, and per 1 molecule how many electrons are there? 1 electron. So what is the n factor for carbon dioxide? 1. But what is the n factor for oxalate? 2, because per 1 ion 2 electrons would be there. Now you can find here from this one, so equivalent weight of oxalate equals to molar mass of oxalate upon n factor how much? 2, and equivalent weight of CO2 equals to molar mass of CO2 upon, what is the n factor? We are getting 2 moles 2 electrons, and 1 molecule 1 electron, so you can say molar mass, and n factor is 1 for CO2 in the given redox reaction. Like this you have to find separately. Question careful, if they are asking particular substance, per that particular substance how many electrons to be transferred, that will be the n factor by given particular reductant or oxidant, right? Let's take another example. Right, another redox reaction. reaction between dichromate Cr2O7 minus 2 plus oxalate ion and giving Cr plus 3 chromic ion plus liberates carbon dioxide, right? Individually you can find in off reaction, or else after getting complete balancing equation also you can get. Both are both conditions we can get same value. Let's see. So first write down the off reaction of dichromate. So 2 Cr plus 3, right? And how many chromium ions here? 2. Here only one is there, so balance. So 2, and you will get here 2x equals to, what is the value? 2x equals to plus 12. Here 2x equals to 1 ion plus 3 and 2 ions plus 6. So difference would be 6 electrons, and now you can get here 6 electrons. Now what is the N factor of dichromate? For 1 ion 6 electrons. So N factor how much here? N factor is 6 for dichromate, and 2 ions 6 electrons. Then per 1 ion how many electrons? 3 electrons. Now what is the N factor for chromic ion Cr plus 3? 3. Now find out the equivalent weight of dichromate. Find out the equivalent weight of dichromate. So equals to molar mass of dichromate upon N factor how much? 6. Next, equivalent weight of Cr plus 3. So molar mass of Cr plus 3 upon 3, because N factor is 3 we got here, right? First half cell. Second half cell same like previous reaction only. So oxalate 2 minus 2 and 2 carbon dioxide plus 2 electrons we can get. So here what is N factor? Per 1 mole 2 electrons, that's why 2, and 2 molecules 2 electrons, then 1 molecule 1 electron is the N factor. So like, and we found already this one in previous redox reaction. So like this we have to find individual elements, right? And now, so how to find how many kinds of equivalent weights are there? How many kinds of equivalent weights are there? So first one is a normal reaction. Equivalent weight equals to molar mass upon N factor. So we found all these conditions. This is a normal condition. And second condition, what is the second condition? Equivalent weight equals to m upon n1 plus m upon n2. So for which it is? This is for disproportionation reaction. Disproportionation reaction. So disproportionation reaction, what is disproportionation reaction? Single substance undergoes oxidation and reduction as well. So what is N1? In oxidation reaction, number of electrons. What is N2? In reduction reaction, number of electrons. Either you can consider this is the reduction reaction N factor, this is oxidation reaction N factor. One is reduction, another one is oxidation. So let's see one example. And if we take so Br2 converts to Br minus plus BrO3 minus. So what are the oxidations here? Br2 bromine oxidation state is 0, and here bromine oxidation state is -1, and the last one bromine oxidation state is +5. So 0 to -1, one reaction means addition of electrons, that is reduction, and 0 to +5 removal of electron, that is oxidation. So one substance undergoes oxidation as well as reduction. Then how to find the equivalent weight of Br2? So let's see, same concept, and from Br2 to Br minus, Br2 to Br minus, and only two atoms are there, here only one atom is there. So multiplied by 2, and we can get 2x equals to 0. Next here 2x equals to -2. So number of electron difference how much here? 2 electrons. Now in this, what is the reaction here? Reduction reaction. In reduction reaction, per one molecule, because we are going to find the equivalent weight of Br2, and it gets disproportionated. It gets disproportionated. So what is the bromine? One molecule, 2 electrons are there, and consider N1 is nothing but a number of N factor for reduction reaction. One molecule, 2 electrons. So what is N factor? 2. Next, the same Br2 molecule so gets into BrO3 minus, BrO3 minus. Here also 2 atoms, only one atom is there. So in balancing equation we have to multiply it by 2, and you can get 2x equals to 0. Here 2x equals to, what is the value? Plus 10. Because one ion has plus 5 and two ions have 2x equals to plus 10. So number difference how much? 10 electrons. Now this is what oxidation reaction. In oxidation reaction, one molecule and 10 electrons are there. So what is the N factor here? N2 equals to 10. N1 equals to 2. Now for disproportionation reactant, so how to find the equivalent weight? Equivalent weight equals to molar mass of that substance upon N1, N factor for reduction, plus molar mass upon N factor for oxidation. Now our equation Br2, equivalent weight of Br2 equals to molar mass of Br2, I am writing directly. So molar mass of Br2 upon N factor is 2 and plus molar mass of Br2 upon N factor is 10. And if you simplify this equation, you can get that. So if you know the bromine Br2 molar mass. And this is how to find the equivalent weight of disproportionated substance. Okay. So this is about equivalent weight of disproportionated substance. And the last one is that if a single substance undergoes reduction reactions both or oxidation reaction both, different ions from a single compound. Let's see. But the last one, last kind of equivalent weight. So equivalent weight equals to molar mass upon N1 plus N2. This is the last one. N1, N2 are, so number of electrons in either both oxidation reactions or reduction reactions. So before the disproportionation reaction, single substance undergoes oxidation and reduction as well, right? But in this one, a single substance of different ions undergoes either both are oxidized or both are reduced. Let's say example, and if we take ferrous oxalate in acidic medium as an oxidant converts to Fe plus 3 plus CO2. Fe plus 3 plus CO2. And in this condition, what is the N factor for ferrous oxalate? What is the N factor for ferrous oxalate? Let's see. And what is the oxidation? This is, I told, ferrous. Ferrous means plus 2 oxidation state. So plus 2 oxidation to plus 3 oxidation it converts, and by liberating 1 electron. So what is the reaction here? Liberation of electron is oxidation. And next one, that oxalate, before that redox reaction we discussed already, oxalate and split into 2 CO2 and liberating 2 electrons. So here also one ion gets oxidation, here also another ion gets oxidized. Of 2 are getting what? Oxidized. 2 are getting oxidized, and actually what is the N factor? Here only one ion is there, so only one ion is there. So one ion, what is the N factor? Here you can say N1 equals to 1. Next, here one ion, here also one ion, and what is N factor? 2. Here N2 equals to 2. Or else, if you add these two equations and Fe plus 2 plus oxalate ion, you can write one molecule of ferrous oxalate plus or minus, and it gives what? Fe plus 3 plus 2 CO2 plus 3 electrons. Or else we can get like this equation also. If you get overall reaction, now per one molecule, how many electrons to be transferred? 3 electrons to be transferred. Now what is the N factor for this ferrous oxalate? 3. That I wrote here directly. Equivalent weight equals to molar mass of that particular substance upon N1 plus N2. Means these two are the N factor for both reduction reaction and both oxidation reaction. What happens here? So it gets what? Oxidation. Here also it gets what? Oxidation. So 2 are oxidation reaction. For that N1 plus N2 becomes how much? 3 here. And from this equation also you have to find that equivalent weight. What is the equivalent weight of ferrous oxalate? So molar mass of that ferrous oxalate upon N factor is 3. Now next question. Equivalent weight of Fe plus 3 ions. equivalent weight, only one ion, number of electrons are 3. That's why here also what is the n factor? So m upon 3. M is nothing but molar mass of Fe plus 3. Next, equivalent weight of CO2 here, equivalent weight of CO2 here. 2 molecule 3 electrons, then 1 molecule 3 by 2 electrons, that is the n factor. So molar mass of CO2 upon, so 3 by 2 is the n factor. Like this we have to find here. This is per 1 molecule how many electrons to be transferred, that is the n factor. Before in the reaction, so CO2 equivalent weight we got I think 1, but in this condition CO2 equivalent weight is 3 by 2. That's why depends on reaction, depends on medium, the n factor would be so varied. Okay, based on that equivalent weight, and you have to find that based on that medium or number of electrons, we have to find the equivalent weight. Now another example, that polymolecule I told in the last video. So polymolecule balancing equation, in basic medium it converts to pH3 plus H2PO2 minus H2PO2 minus, and here you can find I told that balancing equation, consider this is a single atom. So in single atom P2PH3 and x equals to 0, x equals to minus 3. So number of electrons to be added here, how many? 3 electrons to be added. So per 1 phosphorus atom 3 electrons are there. What is the n factor? 3. Next equation P2H2PO2 minus, and here also x equals to 0 to x equals to plus 1, x equals to 0 to x equals to plus 1, because same number of phosphorus atoms are there. And what is the n factor? I mean, what is number of electron difference, how much here? 1. So you should add 1 electron. First reaction is addition of electron, that is what a reduction reaction. Second reaction is removal of electron, that is what oxidation reaction. Here also per 1 atom number of electrons are how many? 1. So that's why what is the n factor here? 1. Now, so this is the disproportionation reaction. For disproportionation reaction, equivalent weight equals to molar mass upon n factor plus molar mass upon n factor. Reductant, oxidant. Now equivalent weight of phosphorus equals to molar mass upon n factor 3 plus molar mass upon n factor 1. And what is the weight of phosphorus? 31. So 31 upon 3 plus 31 upon 1, and you can get 41.3 something, and this would be the answer for the given equation, equivalent weight of P4. If you take P4 also, you can get same answer, no problem at all if you balance, because this is overall a balancing equation, right? So let's see with the P4 balancing equation. So how you got the answer? Let's see. Right, from this equation P4, balance the equation P4 to pH3, and how many phosphorus atoms? 4 phosphorus. That's why this equation is multiplied by 4, and you can get here 4x equals to 0, here 4x equals to, so 1 phosphine, in phosphine minus 3 charge is there, 4 means minus 12 charge. So number of electrons to be added, how many here? 12, right? And P4 1 molecule, so 12 electrons, that's why n factor is 12. Second equation P4 to H2PO2 minus, H2PO2 minus, and here phosphorus atoms are 4, here we have only 1 phosphorus atom, that's why this is multiplied by 4, and here also we can get 4x equals to 0 to 4x equals to plus 4. So number of electrons difference is 4, that's why I added 4 electrons. Now per 1 molecule 4 electrons. So what is the n factor? N2 equals to 4. Now one is a reduction reaction, another one is a oxidation reaction. That nothing but it is a disproportionation reaction for this molecule. So equivalent weight of P4 equals to m upon n1 plus m upon n2. And m is nothing but P4, 1 phosphorus atom, what is the molar mass? 31, but P4 is nothing but 4 into 31 upon first n factor is 12 plus 4 into 31 upon second n factor is 4, right? So 12, 4 3 and 31 by 3 and plus 4 4 get cancelled 31. So we got same answer. Either single atom or polyatomic molecule if you take, and both condition we will get same answer. This is the equivalent weight of phosphorus. P4. Okay, equivalent weight of phosphorus. So this is about equivalent weight. And another equation, simple equation, reaction between nitrogen and ammonia. How to find the equivalent weight? Reaction between nitrogen and ammonia. Suppose N2 converts to ammonia in Haber's process, preparation of ammonia from nitrogen and hydrogen gas. So whatever we have, what is that? 2x equals to 0. But two nitrogen atoms are there. Here we have only one nitrogen atom. That's why this is multiplied by 2, and you can get 2x equals to -6, because in ammonia nitrogen charge is -3, and 2 moles of ammonia we can get 2x equals to -6. So number of electron difference is how much? 6 electron. Now what is the equivalent weight of nitrogen? Per one molecule 6 electrons. So molar mass of nitrogen upon 6. And simple, you know, molar mass of nitrogen is 28 upon 6. Next, equivalent weight of ammonia. So 2 molecules 6 electrons, then per one molecule number of electrons would be 3. That's why n factor for ammonia is 3, whereas n factor for nitrogen is 6. So now molar mass of ammonia upon 3, and molar mass of ammonia, you know, 17 upon 3, and these are the answers. Equivalent weight of nitrogen as well as ammonia in the given equation. So like this you have to find. First what we have to do, find out the individual reactions, half reactions, reduction reaction as well as oxidation reaction. What is the question? Question is about what? If they are asking particular equivalent weight of particular substance, per that substance in 1 mole how many number of moles of electrons would be transferred? That will be the n factor for the given ion. So if they would mention the molar mass in the equation or in the question, or else simple equations are there, you must know that molar mass of the substance like P4, NaOH, H2SO4, like the common compounds are there. So likewise, and we have to find the equivalent weight for a given reductant or oxidant in a redox reaction, and this is about how to find the equivalent weight. So thank you so much. Thank you for watching.